So our video notes tonight are on trigonometry, which is the study of triangle measurement. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. So trigonometric ratios, or we're going to call it trigonometry or trigonometric, we're often going to abbreviate this as trig from now on. So trig ratios are always found in relation to an acute angle. So I'm going to write down now what the ratios of sine, cosine, and tangent are here. So sine is our opposite over our hypotenuse. We'll talk about what these are in a second. Cosine is our adjacent over our hypotenuse. And tangent is our opposite over our adjacent. These sides can change depending on what acute angle we're talking about. So for our first one here, this one is asking for sine of p, cosine of p, and tangent of p. So these sides will be in respect to angle p, not necessarily in respect to other angles. So for angle P, our opposite, which we need for sine and tangent, our opposite is 15. This is the side that does not touch P. This side that is opposite P is the one that does not touch P. So we're going to fill in 15 in the top of sine and the top of tangent, because those are the two places we have opposite. Now we will do our hypotenuse next, which is this longest side, the one that does not touch our right angle. So in this case, 17 is our hypotenuse. We're going to fill that in into the bottom of sine and the bottom of cosine. So those are the two places that we have hypotenuse in our trig ratios. Our final side is our adjacent. Adjacent side is the side that touches P but is not your hypotenuse. So it's the side that touches P and the right angle. So there are two places that's filled in, on the top of cosine and on the bottom of our tangent ratio. So the one to the right is using these in respect to Q. It's asking for sine of Q, cosine of Q, and tangent of Q. So I'm going to circle Q because I find that helps me. And then our hypotenuse is going to be the same, because if you notice, these two triangles are identical. Our hypotenuse is still this longest side opposite the right angle. So the bottom of sine and the bottom of cosine are the same because our hypotenuse goes in the same spot no matter where we're taking our angle from. But our opposite in this case with respect to Q is 8. So 8 here is our opposite. So 8 goes on the top of sine and on the top of tangent. Then our adjacent is the side that touches Q and our right angle. So 15 is our adjacent. So 15 goes on the top of cosine and on the bottom of tangent. So in example 1 here, we're asked to find each trigonometric ratio of angle K and angle J. So I'm going to write out what these should be. So we have sine of K, cosine of K, and tangent of K. We're going to leave a little bit of space after these, and then we're going to write out our three trig ratios for J as well. So we'd have sine of J, cosine of J, and tangent of J. Okay, so when I'm labeling this triangle, because we're trying to find the trig ratios of both k and j. I'm going to do k first, and I'm going to write out the full 3-letter abbreviation for the sides. So from k, 12 is our opposite, 13 is our hypotenuse, and 5 is our adjacent. So we can label our ratios here using this. So sine of k will be opposite over hypotenuse, so that would be 12 over 13. Cosine of k would be adjacent over hypotenuse, so 5 over 13. And tangent of k will be opposite, so 12 over adjacent, which is 5. For j, I'm going to label these sides. I'm sorry if these colors aren't showing up as well as I would have liked. So from j, I'm going to label them all with a 1-letter abbreviation. So j, 13 is still our hypotenuse, 5 is now our opposite, and 12 is our adjacent. So I labeled those with 1-letter abbreviations, so hopefully you can tell which ones are which. So in terms of sine of j is still opposite over hypotenuse. So opposite for j is 5 over hypotenuse is 13. For cosine of j, this will be adjacent, so 12 over 13. And our final one, tangent of j, will be opposite, which is 5 over adjacent in this case, which is 12. Okay, so if we're using trig to find missing side lengths, we first need to set up our trig ratio. So in this case, 25 is our angle, so we need to know what x and 18 are in order to use the correct trig ratio. So x in this case is opposite 25, it does not touch 25, and 18 touches this 25-degree angle and our right angle, so 18s are adjacent. Our trig ratio, which uses both opposite and adjacent, is tangent. So we can say tangent of 25 degrees equals x over 18. Then we want to get x by itself, obviously. So in order to do this, we need to multiply 18 to the other side. So you would have 18 times tan of 25 degrees equals x. You will need to use a calculator to find out this answer. And our answer here is that x is approximately equal to 8.39. We can talk about how to do this in your calculator if you're confused in class next time. So our next triangle here for number 2, we're talking about 70 degrees. So 70 degrees is our angle we're looking from. We do not have an opposite here. This is a blank side, so that's not very helpful to us. X is our hypotenuse, and 15 is our adjacent. So our trig ratio with with hypotenuse and adjacent is cosine. And so cosine of 70 degrees equals 15 over x. So to get x by itself, we first have to multiply it to the other side. So with that, we can say x times cosine of 70 degrees equals 15. And now to get x even completely by itself, we could say x equals 15 divided by cosine of 70 degrees. And this is approximately equal to 43.86. Again, you'll need a calculator for this. We can talk about how to do this later on. So our final triangle here has 62 degrees as our angle, and x in this case is our opposite. So x is our opposite, and 10 is our hypotenuse. So with an opposite and a hypotenuse, we know we'll need to use the sine function. So sine of 62 degrees is equal to our opposite over our hypotenuse, so x over 10. So we can say that 10 times sine of 62 degrees equals x. So our final answer here is that x is approximately equal to 8.83. So when we have inverse trig ratios, these are, we could call it the opposite. I don't love this word, but I can't think of a better one at this time, are the opposite of our regular trig ratios. And inverse trig ratios are used in right triangles to find those acute angles. So our ratios here, so this would be sine inverse of opposite over hypotenuse, cosine inverse of adjacent over hypotenuse, and tan inverse of opposite over adjacent in order to find those missing angles. So in this case, we need to make sure we're still circling our angle so we know what trig ratios to use. So this is angle B. So 27 is our hypotenuse and 18 is our adjacent. So cosine of B equals 18 over 27, right? Because we have adjacent and hypotenuse, we would use cosine. So then we can say the measure of angle B equals cosine inverse of 18 over 27, and we get an approximate measure of angle B of 48.19 degrees. We can talk about how to type this into your calculator in class. So for number 2, we're referring to angle A. So in angle A, 6 is our opposite because it doesn't touch angle A, and 20 is our adjacent. Our trig function that uses opposite and adjacent is tangent. So tangent of A is equal to opposite 6 over adjacent 20. So we can say the measure of angle A equals tangent inverse of 6 over 20, which gives us an approximate measure for angle A of 16.7 degrees. And our final triangle here, we are referring to angle B. And some of you may be able to guess here, since 3 is our opposite and 15 is our hypotenuse, that we're going to use sine because we used cosine for the first one, tangent for the second one. So we're using sine here. So we can say sine of B is equal to our opposite over our hypotenuse. So this case is 13 over 15. And so measure of angle B is equal to sine inverse of 3 over 15. Then the measure of angle B is approximately 11.54 degrees. All right, so I will see you all in class on Thursday.